Aphorisms 48 part 2, 49, and 50 part 1 of Book 2 of the New Organon. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. Recording by Jeffrey Edwards. The New Organon by Francis Bacon. Translated by James Spedding, Robert Leslie Ellis, and Douglas Denon Heath. Aphorisms 48 part 2, 49, and 50 part 1 of Book 2. Let the 13th motion be the motion of impression, which also is of the same genus with the motion of assimilation, and is of diffusive motions the most subtle. I have thought fit, however, to make a distinct species of it, on account of a remarkable difference between it and the two former. For the simple motion of assimilation actually transforms the bodies themselves, so that you may take away the first mover, and there will be no difference in what follows. For the first kindling into flame, or the first turning into air, has no effect on the flame or air next generated. In like manner, the motion of excitation continues, after the first mover is withdrawn, for a very considerable time, as in a heated body when the primary heat has been removed, in magnetized iron when the magnet has been put away, in dough when the leaven has been taken out. But the motion of impression, though diffusive and transitive, seems to depend for ever on the prime mover, so that if that be taken away or cease to act, it immediately fails and comes to an end. And therefore the effect must be produced in a moment, or at any rate in a very brief space of time. The motions therefore of assimilation and excitation I call motions of the generation of Jupiter, because the generation continues, but this, the motion of the generation of Saturn, because the birth is immediately devoured and absorbed. It manifests itself in three things: in rays of light, in the percussions of sounds, and in magnetism, as regards the communication of the influence. For if you take away light, colours and its other images instantly disappear. If you take away the original percussion and the vibration of the body thence produced, the sound soon after dies away. For though sounds are troubled as they pass through their medium by winds, as if by waves, yet it must be carefully noted that the original sound does not last all the time the resonance goes on. For if you strike a bell, the sound seems to be continued for a good long time, whereby we might easily be led into the error of supposing that during the whole of the time the sound is, as it were, floating and hanging in the air, which is quite untrue. For the resonance is not the identical sound, but a renewal of it, as is shown by quieting or stopping the body struck. For if the bell be held tight so that it cannot move, the sound at once comes to an end and resounds no more. As in stringed instruments, if after the first percussion the string be touched, either with the finger, as in the harp, or with the quill, as in the spinet, the resonance immediately ceases. Again, when the magnet is removed, the iron immediately drops. The moon indeed cannot be removed from the sea, nor the earth from the falling body, and therefore we can try no experiment in these cases, but the principle is the same. Let the 14th motion be the motion of configuration or position, by which bodies seem to desire not union or separation, but position, collocation, and configuration with respect to others. This motion is a very abstruse one, and has not been well investigated. In some cases, indeed, it seems to be without a cause, though not, I believe, really so. For if it be asked why the heavens revolve rather from east to west than from west to east, or why they turn on poles placed near the Bears rather than about Orion, or in any other part of heaven, such questions seem to border on insanity, since these phenomena ought rather to be received as results of observation, and merely positive facts. But though there are no doubt in nature certain things ultimate and without cause, this does not appear to me to be one of them, being caused in my opinion by a certain harmony and consent of the universe which has not yet fallen under observation. And if we admit the motion of the earth from west to east, the same questions remain, for it also moves on certain poles. And why, it might be asked, should these poles be placed where they are, rather than anywhere else? Again, the polarity, direction, and declination of the magnet are referable to this motion. There are also found in bodies natural as well as artificial, especially in solids, a certain collocation and position of parts, and a kind of threads and fibres which ought to be carefully investigated since, until they are understood, these bodies cannot be conveniently managed or controlled. But those eddyings in fluids, by which when pressed, before they can free themselves, they relieve each other, that they may all have a fair share of the pressure, belonging more properly to the motion of liberty. Let the 15th motion be the motion of transition, or motion according to the passages, by which the virtues of bodies are more or less impeded or promoted by their media, according to the nature of the body and of the acting virtues, and also of the medium. For one medium suits light, another sound, another heat and cold, another magnetic virtues, and so on. Let the 16th motion be the royal, as I call it, or political motion, by which the predominant and commanding parts in any body curb, tame, subdue, and regulate the other parts, and compel them to unite, separate, stand still, move, and range themselves, not in accordance with their own desires, but as may conduce to the well-being of the commanding part. So that there is a sort of government and polity exerted by the ruling over the subject parts. This motion is eminently conspicuous in the spirits of animals where, as long as it is in vigour, it tempers all the motions of the other parts. It is found, however, in other bodies in a lower degree, as I said of blood and urine, which are not decomposed till the spirit which mixes and keeps together their parts be discharged or quenched. Nor is this motion confined to spirits, though in most bodies the spirits are masters owing to their rapid and penetrating motion. But in bodies of greater density and not filled with a lively and quickening spirit, such as there is in quicksilver and vitriol, the thicker parts are the masters, so that unless this yoke and restraint be by some expedient shaken off, there is very little hope of any new transformation of such bodies. But let no one suppose that I am forgetful of the point at issue, because while this series and distribution of motions tends to nothing else but the better investigation of their predominancy by instances of strife, I now make mention of predominancy among the motions themselves. For in describing this royal motion I am not treating of predominancy of motions or virtues, but of the predominancy of parts in bodies, such being the predominancy which constitutes the peculiar species of motion in question. Let the 17th motion be the spontaneous motion of rotation, by which bodies delighting in motion and favourably placed for it enjoy their own nature, and follow themselves, not another body, and court, so to speak, their own embraces. For bodies seem either to move without limit, or to remain altogether at rest, or to tend to a limit at which, according to their nature, they either revolve or rest. Those which are favourably placed, if they delight in motion, move in a circle, with a motion that is eternal and infinite. Those which are favourably placed and abhor motion, remain at rest. Those which are not favourably placed move in a right line, as the shortest path, to consort with bodies of their own nature. But this motion of rotation admits of 9 differences regarding: 1. The centre round which the bodies move. 2. The poles on which they move. 3. Their circumference or orbit, according to their distance from the centre. 4. Their velocity, according to the greater or less rapidity of their rotation. 5. The course of their motion, as from east to west, or from west to east. 6. their declination from a perfect circle by spiral lines more or less distant from their centre. 7. Their declination from a perfect circle by spiral lines more or less distant from their poles. 8. The greater or lesser distance of these spirals from each other. 9. And lastly, the variation of the poles themselves, if they be movable, which, however, has nothing to do with rotation unless it be circular. This motion in common and long received opinion is looked upon as the proper motion of heavenly bodies, though there is a grave dispute with regard to it among some both of the ancients and of the moderns, who have attributed rotation to the earth. But a juster question perhaps arises upon this, if it be not past question, namely, whether this motion, admitting that the earth stands still, is confined to the heavens, and does not rather descend and communicate itself to the air and waters. The motion of rotation in missiles, as in darts, arrows, musket balls, and the like, I refer to the motion of liberty. Let the 18th motion be the motion of trepidation, to which, as understood by astronomers, I do not attach much credit. But in searching carefully everywhere for the appetites of natural bodies, this motion comes before us and ought, it seems, to constitute a species by itself. It is a motion of what may be called perpetual captivity, and occurs when bodies that have not quite found their right place, and yet are not altogether uneasy, keep for ever trembling and stirring themselves restlessly, neither content as they are nor daring to advance further. Such a motion is found in the heart and pulses of animals, and must of necessity occur in all bodies which so exist in a mean state between conveniences and inconveniences, that when disturbed they strive to free themselves, and being again repulsed, are yet forever trying again. Let the 19th and last motion be one which, though it hardly answers to the name, is yet indisputably a motion. And let us call it the motion of repose, or of aversion to move. It is by this motion that the earth stands still in its mass, while its extremities are moving toward the middle, not to an imaginary centre, but to union. By this appetite also all bodies of considerable density abhor motion. Indeed, the desire of not moving is the only appetite they have. And though in countless ways they be enticed and challenged to move, they yet, as far as they can, maintain their proper nature. And if compelled to move, they nevertheless seem always intent on recovering their state of rest and moving no more. While thus engaged, indeed, they show themselves active and struggle for it with agility and swiftness enough, as weary and impatient of all delay. Of this appetite but a partial representation can be seen, since here with us, from the subduing and concocting power of the heavenly bodies, all tangible substances are not only not condensed to their utmost, but are even mixed with some portion of spirit. Thus then have I set forth the species or simple elements of motion, appetites, and active virtues, which are in nature most general. And under these heads no small portion of natural science is sketched out. I do not, however, mean to say that other species may not be added, or that the divisions I have made may not be drawn more accurately according to the true veins of nature, or reduced to a smaller number. Observe, nevertheless, that I am not here speaking of any abstract divisions, as if one were to say that bodies desire either the exaltation or the propagation or the fruition of their nature, or again, that the motions of things tend to the preservation and good either of the universe, as resistance and connection, or of great wholes, as the motions of the greater congregation, rotation, and aversion to move, or of special forms, as the rest. For though these assertions be true, yet unless they be defined by true lines in matter and the fabric of nature, they are speculative and of little use. Meanwhile, these will suffice and be of good service in weighing the predominancies of virtues and finding out instances of strife, which is our present object. 4 of the motions I have set forth, some are quite invincible, some are stronger than others, fettering, curbing, arranging them. Some carry farther than others, some outstrip others in speed, some cherish, strengthen, enlarge, and accelerate others. The motion of resistance is altogether adamantine and invincible. Whether the motion of connexion be so, I am still undecided. For I am not prepared to say for certain whether or no there be a vacuum, either collected in one place, or interspersed in the pores of bodies. But of one thing I am satisfied, that the reason for which a vacuum was introduced by Leucippus and Democritus, namely, that without it the same bodies could not embrace and fill sometimes larger and sometimes smaller spaces, is a false one. For matter is clearly capable of folding and unfolding itself in space, within certain limits, without the interposition of a vacuum. Nor is there in air 2,000 times as much of vacuity as there is in gold, which, on their hypothesis, there should be. Of this I am sufficiently convinced by the potency of the virtues of pneumatical bodies, which otherwise would be floating in empty space like fine dust, and by many other proofs. As for the other motions, they rule and are ruled in turn, in proportion to their vigour, quantity, velocity, force of projection, and also to the helps and hindrances they meet with. For instance, there are some armed magnets that hold and suspend iron of 60 times their own weight. So far does the motion of the lesser prevail over the motion of the greater congregation. But if the weight be increased, it is overcome. A lever of given strength will raise a given weight. So far does the motion of liberty prevail over that of greater congregation. But if the weight be increased, it is overcome. Leather stretches to a certain extent without breaking. So far does the motion of continuity prevail over the motion of tension. But if the tension be increased, the leather breaks, and the motion of continuity is overcome. Water runs out of a crack of a certain size. So far does the motion of the greater congregation prevail over the motion of continuity. But if the crack be smaller, it gives way, and the motion of continuity prevails. If you charge a gun with ball and sulphur only, and apply the match, the ball is not discharged, the motion of the greater congregation overcoming in this case the motion of matter. But if you charge with gunpowder, the motion of matter in the sulphur prevails, being aided by the motions of matter and of flight in the nitre. And so of other cases. Instances of strife, therefore, which point out the predominancies of virtues together with the manner and proportion in which they predominate or give place, should be sought and collected from all quarters with keen and careful diligence. Nor should we examine less carefully the modes in which these motions give way. That is to say, whether they stop altogether, or whether they continue to resist, but are overpowered. For in bodies here with us there is no real rest, either in wholes or in parts, but only in appearance, and this apparent rest is caused either by equilibrium or by absolute predominancy of motions. By equilibrium, as in scales, which stand still if the weights be equal; by predominancy, as in watering pots with holes in them, where the water rests and is kept from falling out by the predominancy of the motion of connexion. But it should be observed, as I have said, how far these yielding motions carry their resistance. For if a man be pinned to the ground, tied hand and foot, or otherwise held fast, and yet struggle to rise with all his might, the resistance is not the less though it be unsuccessful. But the real state of the case, I mean whether by predominancy the yielding motion is, so to speak, annihilated, or rather whether a resistance is continued, though we cannot see it, will perhaps, though latent in the conflicts of motions, be apparent in their concurrence. For example, let trial be made in shooting. See how far a gun will carry a ball straight, or as they say point blank, and then try whether, if it be fired upward, the stroke will be feebler than when it is fired downward, where the motion of gravity concurs with the blow. Lastly, such canons of predominance as we meet with should be collected. For instance, that the more common the good sought, the stronger the motion. Thus the motion of connexion, which regards communion with the universe, is stronger than the motion of gravity, which regards only communion with dense bodies. Again, that appetites which aim at a private good seldom prevail against appetites which aim at a more public good, except in small quantities. rules which I wish held good in politics. Section 49. Among prerogative instances, I will put in the 25th place intimating instances, those, I mean, which intimate or point out what is useful to man. For mere power and mere knowledge exalt human nature, but do not bless it. We must therefore gather from the whole store of things such as make most for the uses of life. But a more proper place for speaking of these will be when I come to treat of applications to practice. Besides, in the work itself of interpretation in each particular subject, I always assign a place to the human chart, or chart of things to be wished for. For to form judicious wishes is as much a part of knowledge as to ask judicious questions. Section 50. Among prerogative instances, I will put in the 26th place polycrest instances, or instances of general use. They are those which relate to a variety of cases and occur frequently, and therefore save no small amount of labour and fresh demonstration. Of the instruments and contrivances themselves, the proper place for speaking will be when I come to speak of applications to practice and modes of experimenting. Moreover, those which have been already discovered and come into use will be described in the particular histories of the several arts. At present I will subjoin a few general remarks on them as examples merely of this general use. Besides the simple bringing together and putting asunder of them, man operates upon natural bodies chiefly in 7 ways, viz. Either by exclusion of whatever impedes and disturbs, or by compressions, extensions, agitations, and the like, or by heat and cold, or by continuance in a suitable place, or by the checking and regulation of motion, or by special sympathies, or by the seasonable and proper alternation, series, and succession of all these ways, or at any rate of some of them. With regard to the first, the common air, which is everywhere about us and pressing in, and the rays of the heavenly bodies, cause much disturbance. Whatever therefore serves to exclude them may justly be reckoned among things of general use. To this head belong the material and thickness of the vessels in which the bodies are placed on which we are going to operate. Also the perfect stopping up of vessels by consolidation and lutum sapientiae, as the chemists call it. Also the closing in of substances by liquids poured on the outside is a thing of very great use, as when they pour oil on wine or juices of herbs, which spreading over the surface like a lid preserves them excellently from the injury of the air. Nor are powders bad things, for though they contain air mixed up with them, they yet repel the force of the body of air round about, as we see in the preservation of grapes and other fruits in sand and flour. It is good too to spread bodies over with wax, honey, pitch, and like tenacious substances, for the more perfect enclosure of them and to keep off the air and heavenly bodies. I have sometimes tried the effect of laying up a vessel or some other body in quicksilver, which of all substances that can be poured round another is far the densest. Caverns, again, and subterraneous pits are of great use in keeping off the heat of the sun, and that open air which preys upon bodies, and such are used in the north of Germany as granaries. The sinking of bodies in water has likewise the same effect, as I remember to have heard of bottles of wine being let down into a deep well to cool, but through accident or neglect being left there for many years, and then taken out, and that the wine not only was free from sourness or flatness, but tasted much finer, owing, it would seem, to a more exquisite commixture of its parts. And if the case require that bodies be let down to the bottom of the water, as in a river or the sea, without either touching the water or being enclosed in stopped vessels, but surrounded by air alone, there is good use in the vessel which has been sometimes employed for working under water on sunk ships, whereby divers are enabled to remain a long while below, and take breath from time to time. This machine was a hollow bell made of metal which, being let down parallel to the surface of the water, carried with it to the bottom all the air it contained. It stood on 3 feet, like a tripod, the height of which was somewhat less than that of a man, so that the diver, when his breath failed, could put his head into the hollow of the bell, take breath, and then go on with his work. I have heard also of a sort of machine or boat capable of carrying men under water for some distance. Be that as it may, under such a vessel as I have described, bodies of any sort can easily be suspended, and it is on that account that I have mentioned this experiment. There is also another advantage in the careful and complete closing of bodies, for not only does it keep the outer air from getting in, of which I have already spoken, but also it keeps the spirit of the body, on which the operation is going on inside, from getting out. For it is necessary for one who operates on natural bodies to be certain of his total quantities, that is, that nothing evaporates or flows away. For then, and then only, are profound alterations made in the bodies when, while nature prevents annihilation, art prevents also the loss or escape of any part. On this subject there has prevailed a false opinion which, if true, would make us well nigh despair of preserving the perfect quantity without diminution, namely, that the spirits of bodies, and air when rarefied by a high degree of heat, cannot be contained in closed vessels, but escape through their more delicate pores. To this opinion men have been led by common experiment of an inverted cup placed on water, with a candle in it or a piece of paper lighted, the consequence of which is that the water is drawn up, and also by similar experiments of cupping glasses which when heated over flame draw up the flesh. For in each of these experiments they imagine that the rarefied air escapes, and that its quantity being thereby diminished, the water or flesh comes up into its place by the motion of connection. But this is altogether a mistake, for the air is not diminished in quantity, but contracted in space, nor does the motion of the rising of the water commence till the flame is extinguished or the air is cooled. And therefore physicians, to make their cupping glasses draw better, lay on them a cold sponge dipped in water. And therefore there is no reason why men should be much afraid of the easy escape of air or spirits. For though it be true that the most solid bodies have pores, still air or spirit do not easily submit to such extremely fine comminution, just as water refuses to run out at very small chinks. With regard to the second of the 7 modes of operating above mentioned, it is particularly to be observed that compression and such violent means have indeed, with respect to local motion and the like, a most powerful effect, as in machines and projectiles, an effect which even causes the destruction of organic bodies and of such virtues as consist altogether in motion. For all life, nay, all flame and ignition, is destroyed by compression, just as every machine is spoiled or deranged by the same. It causes the destruction likewise of virtues which consist in the position and coarser dissimilarity of parts. This is the case with colours, for the whole flower has not the same colour, as when it is bruised, nor the whole piece of amber, as the same piece pulverized. So also it is with tastes. For there is not the same taste in an unripe pear as there is in a squeezed and softened one. For it manifestly contracts sweetness by the process. But for the more remarkable transformations and alterations of bodies of uniform structure, such violent means are of little avail, since bodies do not acquire thereby a new consistency that is constant and quiescent, but one which is transitory, and ever striving to recover and liberate itself. It would not be amiss, however, to make some careful experiments for the purpose of ascertaining whether the condensation or the rarefaction of a body of nearly uniform structure, as air, water, oil, and the like, being induced by violence, can be made to be constant and fixed, and to become a kind of nature. This should first be tried by simple continuance, and then by means of helps and consents, and the trial might easily have been made, if it had but occurred to me, when I was condensing water, as mentioned above, by hammer and press, till it burst forth from its enclosure. For I should have left the flattened sphere to itself for a few days, and after that drawn off the water, that so I might have seen whether it would immediately occupy the same dimensions which it had before condensation. If it had not done so, either immediately or at any rate soon after, we might have pronounced the condensation a constant one. If it had, it would have appeared that a restoration had taken place and that the compression was transitory. Something of a similar kind I might have tried also with the expansion of air in the glass eggs. For For after powerful suction I might have stopped them suddenly and tightly. I might have left the egg so stopped for some days, and then tried whether on opening the hole the air would be drawn up, with a hissing noise, or whether on plunging them into water, as much water would be drawn up as there would have been at first without the delay. For it is probable, at least it is worth trying, that this might have been and may be the case. Since in bodies of structure not quite so uniform the lapse of time does produce such effects. For a stick bent for some time by compression does not recoil. And this must not be imputed to any loss of quantity in the wood through the lapse of time, since the same will be the case with a plate of steel, if the time be increased, and steel does not evaporate. But if the experiment succeed not with mere continuance, the business must not be abandoned, but other aids must be employed. For it is no small gain if by the application of violence we can communicate to bodies fixed and permanent natures. For thus air can be turned into water by condensation, and many other effects of the same kind can be produced, man being more the master of violent motions than of the rest. End of Aphorisms 48 Part 2, 49 and 50 Part 1 of Book 2. Recording by Jeffrey Edwards.